What does it mean when we say that a number goes into another number evenly? Well, it means that there's no remainder, right? So we say that 7 goes into 14 evenly because 14 divided by 7 is equal to 2 with no remainder. So conversely, it doesn't go into it evenly when there is a remainder. So 15 divided by 7 is equal to 2, remainder 1. Or sometimes we might write that as 2 and 1/7. So there's a remainder. And because polynomials are simply numbers with variables in them, remember that they are just numbers. The same applies to that as well. If I divide two polynomials, I can get a remainder, and that's what we're going to have a look at today. Last lesson, we had a look at dividing a polynomial by another one using the reverse method. That is on slide 11 on your screen now. On slide 12, you can see I've got two polynomials almost identical, but in this instance, I've got 5x plus 7 instead of 5x plus 6. So that already should send an alarm bell that it's not going to go in evenly, since when I had 6 there, it did. But you know what? The good news is it's actually the same process. So I start off with my box method, like so. And I look at the leading term, which is x squared, and that goes inside this box here. Okay, I'll put a little red dot in it there, and there's a little red dot underneath. Okay, I know that q of x, the thing I'm dividing by, goes on this edge here, x plus 3, like so. And now I follow the pathway through. I know that it's x times something to give me x squared, and so I pop the x up here. X times x is x squared. I therefore can work out this bottom box here. X times 3 is equal to 3x, so that can be now filled in. I look at my middle term, it's 5x, and I know that across the diagonals here, that has to add up to 5x, like so. So I can fill out the top box here, and it's 2x. I can now fill out this part here because x times what will give me 2x, and of course the answer is 2, but here's where it gets interesting, or positive 2 is useful, because if I work out what 3 times 2 is, I get 6, but my polynomial says plus 7, so it means I've got a remainder of 1, and that's what makes it different. Okay, so I'm looking for 7, so I've got 6 plus another 1 to make it up to. How do we write that? Well, it's very similar. We've got, sorry, wrong color, p of x divided by q of x, or x squared plus 5x plus 7 divided by x plus 3, is equal to x plus 3 remainder 1. Sorry, x plus 2 remainder 1, sorry. Whoops. X plus 2 remainder 1. It's not a common way of writing it, but it does give the give what you want. But remember how when I went 15 divided by 7 is equal to 2 remainder 1, which is 2 and 1/7. We can do the same thing here. So we can write x plus 2 plus 1 over x plus 3. Okay, the divided by 7, divide by x plus 3, so the x plus 3 is there. So that is legitimately what p of x divided by q of x is equal to. I'll just go underneath here for another way of writing it. We can also write, just like we can write 15 is equal to 7 times 2 plus 1, i.e. the two factors we had plus the remainder, we can also do the same thing to the polynomial. So we can say the polynomial is equal to x plus 3 times by x plus 2 plus the remainder. Okay, so it's equivalent to exactly what we're doing with regular old whole number division, but we're just doing it with fancy schmancy algebraic expressions instead. Okay, I'll leave this video here, and in the next video, we'll keep on diving deeper into polynomial division. Thanks for watching.